When routing electrical feeders through retail ceilings in a mixed-use building, several code and design issues need consideration. Firstly, addressing code issues. National Electrical Code, or NEC, Article 220.10 dictates that conductors must be protected from physical damage. Running feeders through retail ceilings may violate this requirement if the ceilings are not protected from accidental damage. Secondly, NEC Article 230.41 states that feeders must be readily accessible for inspection and maintenance. Concealing feeders in retail ceilings may make them difficult to access. Thirdly, NEC Article 300.22 requires that conductors must be securely fastened and supported. Securing feeders in retail ceilings may require additional supports or conduits. Beyond code compliance, several design issues also warrant attention. Feeders carrying high currents can generate heat. Routing them through ceilings may create a fire hazard if the heat is not dissipated effectively. Commercial ceilings are often fully utilized for lighting, heating, ventilation, and air conditioning or HVAC and other equipment. Routing feeders through these ceilings may require complex bends or support systems. Penetrating retail ceilings to route feeders may weaken the ceiling structure if not properly reinforced. Exposed feeders in retail ceilings may be unsightly and detract from the space's appearance. Running feeders through ceilings may interfere with retail activities, such as moving inventory or installing displays. To mitigate these issues, consider several possible solutions. One potential solution is to install a meter center in the basement or on a higher floor. This eliminates the need to route feeders through retail ceilings. Another solution is to use concealed raceways or conduits. These enclosures can protect feeders from physical damage and provide access for inspection and maintenance. Provide adequate spacing and support. Ensure there is sufficient space between feeders and adjacent equipment for heat dissipation. Use appropriately rated supports to secure feeders in place. Coordinate with retail tenants. Work with tenants to minimize interference with their operations and ensure an aesthetically pleasing installation. Let's delve into more detail regarding these considerations. Firstly, concerning physical damage protection under NEC 220.10, the retail environment presents numerous opportunities for accidental damage to electrical feeders. Consider scenarios such as forklifts maneuvering inventory, display setups being modified, or even routine maintenance activities. Without adequate protection, feeders are vulnerable to impacts, abrasions, and punctures. To address this, several strategies can be employed. One option is to encase the feeders in rigid metal conduit, or RMC, which provides a robust shield against physical threats. Intermediate metal conduit, or IMC, offers a lighter weight alternative while still providing substantial protection. Electrical metallic tubing, or IMD, may be suitable for areas where the risk of severe impact is low, but it's essential to ensure it's properly supported and secured. Another approach is to utilize cable trays with covers. Cable trays offer a convenient way to route multiple feeders and provide a degree of physical protection, especially when equipped with solid or ventilated covers. The choice of protection method should be based on a thorough assessment of the specific hazards present in the retail environment. Secondly, accessibility for inspection and maintenance, as mandated by NEC 230.41, is crucial for ensuring the long-term reliability and safety of the electrical system. Concealing feeders behind permanent ceilings or walls can create significant challenges for inspectors and maintenance personnel. To address this, several strategies can be employed to enhance accessibility. One option is to install access panels at strategic locations along the feeder route. These panels should be large enough to allow for visual inspection on physical access to the feeders and any associated connections or splices. Clearly labeling the access panels with appropriate warnings and identification information is also essential. Another approach is to utilize removable ceiling tiles or panels along the feeder route. This allows for easy access to the feeders without the need for specialized tools or equipment. When designing the feeder route, it's important to avoid running feeders behind obstructions such as ductwork, piping, or structural members. These obstructions can make it difficult to reach the feeders and perform necessary maintenance tasks. Thirdly, secure fastening and support, as required by NEC 300.22, are essential for preventing stress on the conductors and ensuring the long-term integrity of the electrical system. Feeders that are not properly supported can sag, vibrate, or even detach from their supports, leading to insulation damage, conductor breakage, and potential fire hazards. To address this, several strategies can be employed. One option is to use appropriately sized and spaced conduit clamps or straps to secure the feeders to the building structure. The spacing between supports should be in accordance with NEC requirements and manufacturer recommendations. Another approach is to utilize cable trays with appropriate support hardware. Cable trays provide a stable and secure platform for routing feeders, and they can be easily supported from the ceiling or walls. When securing feeders, it's important to avoid over-tightening the clamps or straps, as this can damage the insulation and reduce the current carrying capacity of the conductors. Heat dissipation is another critical design consideration, particularly for feeders carrying high currents. The heat generated by these feeders can raise the ambient temperature in the ceiling space, potentially leading to overheating, insulation degradation, and even fire hazards. To address this, several strategies can be employed. One option is to increase the size of the conductors to reduce the current density and heat generation. This can be achieved by using larger gauge conductors or by paralleling multiple smaller conductors. Another approach is to provide adequate ventilation in the ceiling space to dissipate the heat. This can be achieved by installing ventilation fans, louvers, or other means of promoting airflow. When routing feeders through insulated ceilings, it's important to ensure that there is sufficient airspace around the feeders to allow for heat dissipation. The NEC provides specific requirements for conductor opacity routing in high-temperature environments, and these requirements should be carefully followed. Space constraints in commercial ceilings often pose a significant challenge when routing electrical feeders. These ceilings are typically packed with lighting fixtures, heating, ventilation and air conditioning or HVAC ductwork, piping, and other equipment, leaving little room for additional infrastructure. To address this, careful planning and coordination are essential. One approach is to utilize compact conduit or cable tray systems that minimize the space required for routing feeders. Another option is to consolidate multiple feeders into a single conduit or cable tray, reducing the overall footprint of the electrical installation. When routing feeders through tight spaces, it's important to avoid sharp bends or kinks in the conductors, as these can increase the risk of insulation damage and conductor breakage. The structural integrity of the retail ceiling must also be considered when routing electrical feeders. Penetrating the ceiling to install conduits, cable trays, or other support hardware can weaken the ceiling structure if not properly reinforced. To address this, it's important to consult with a structural engineer to ensure that the ceiling can safely support the weight of the electrical installation. When penetrating the ceiling, it's important to use appropriate drilling techniques and to avoid damaging any structural members. The aesthetics of the electrical installation should also be considered, particularly in retail environments where appearance is important. Exposed conduits, cable trays, or other electrical equipment can detract from the overall look and feel of the space. To address this, several strategies can be employed. One option is to conceal the feeders behind ceilings, walls, or other architectural features. Another approach is to use decorative conduit or cable tray systems that blend in with the surrounding decor. When routing feeders in exposed areas, it's important to keep them neat, organized, and free of dust and debris. Finally, the potential for interference with retail operations should be considered when routing electrical feeders. Running feeders through ceilings can disrupt retail activities such as moving inventory, installing displays, or performing maintenance tasks. To address this, it's important to coordinate with retail tenants to minimize any disruptions. This can be achieved by scheduling electrical work during off-peak hours, providing temporary power to affected areas, and communicating clearly about the scope and duration of the work. In addition to these considerations, it's also important to comply with all applicable electrical codes and regulations. The NEC provides detailed requirements for the installation of electrical feeders, and these requirements should be carefully followed. It's also important to obtain all necessary permits and inspections before beginning any electrical work. By carefully considering these code and design issues, you can ensure that the electrical feeders in your mixed-use building are installed safely, reliably, and in a way that minimizes disruption to retail operations. Now let's break down the NEC articles mentioned in more detail. Article 220.10 focuses on branch circuit, feeder, and service calculations, specifically the general requirements. It mandates that the load calculations must include sufficient capacity to handle the anticipated electrical demands of the building or occupancy. It also states that the conductors must have sufficient ampacity for the calculated loads, considering voltage drop and other factors. The conductors must be protected against overcurrent in accordance with their ampacity. Article 230.41 pertains to service entrance conductors, specifically their sizing. It dictates that service entrance conductors must have sufficient ampacity to carry the calculated load as determined by Article 220. The ampacity of the service entrance conductors must not be less than the rating of the service disconnecting means. For one-family dwellings, the service entrance conductors must have an ampacity of not less than 100 amps, 3-wire. Article 300.22 covers wiring methods for wiring in ducts, plenums, and other environmental airspaces. It states that the wiring methods used in ducts used to transport dust, loose stock, or flammable vapors must be metal raceways or metal-clad cables. Wiring methods installed in ducts or plenums used for environmental air must be listed as suitable for the purpose. Cables and conductors installed in other spaces used for environmental air must be listed as suitable for the purpose or be installed in metal raceways. Remember to always consult the latest edition of the National Electrical Code in local amendments for specific requirements and interpretations in your area. Furthermore, let's consider some additional practical tips for routing electrical feeders through retail ceilings. Firstly, conduct a thorough site survey. Before beginning any design or installation work, conduct a thorough site survey to identify potential obstacles, hazards, and space limitations. This survey should include a detailed examination of the existing ceiling structure, lighting fixtures, heating, ventilation, and air conditioning or HVAC ductwork, piping, and other equipment. Secondly, create detailed drawings. Develop detailed drawings that show the proposed feeder route, including the location of conduits, cable trays, supports, and access panels. These drawings should be reviewed by all stakeholders, including the building owner, retail tenants, and electrical inspector, to ensure that the installation meets their needs and requirements. Thirdly, use prefabricated components. Utilize prefabricated conduit or cable tray systems whenever possible to reduce installation time and minimize disruption to retail operations. These systems can be customized to fit specific site conditions and can be easily assembled on site. Fourthly, label all components clearly. Label all conduits, cable trays, supports, and access panels clearly with appropriate warnings and identification information. This will help to ensure that the electrical system can be easily inspected, maintained, and repaired in the future. Fifthly, test and inspect the installation. After completing the installation, test and inspect the entire system to ensure that it is working properly and that it meets all applicable code requirements. They should include a visual inspection, continuity testing, insulation resistance testing, and load testing. Sixthly, provide training to maintenance personnel. Provide training to building maintenance personnel on the proper operation and maintenance of the electrical system. This training should include information on the location of feeders, the operation of overcurrent protection devices, and the procedures for troubleshooting and repairing electrical problems. By following these practical tips, you can help to ensure that the electrical feeders in your mixed-use building are installed safely, reliably, and in a way that minimizes disruption to retail operations. And it is also important to choose the right type of feeder cable. The type of cable you select for your feeders depends on several factors, including the ampacity requirements, the environmental conditions, and the installation method. Some common types of feeder cable include THHN/THWN, XHHW, and MC cable. THHN/THWN conductors are commonly used for general-purpose wiring in dry or damp locations. XHHW conductors are suitable for use in wet or dry locations and have a higher temperature rating than THHN/THWN conductors. Metal-clad or MC cable is a pre-assembled cable that consists of insulated conductors enclosed in a flexible metal sheath. MC cable is often used for exposed wiring or wiring in concealed locations where physical protection is required. It is also important to properly size your feeder conductors to ensure that they can safely carry the required current. The NEC provides tables that specify the ampacity of different types of conductors based on their size and temperature rating. When sizing your feeder conductors, it is important to consider the ambient temperature and any dirting factors that may apply. Also remember that overcurrent protection is a critical aspect of feeder design. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors from overload and short-circuit conditions. The NEC requires that feeder conductors be protected by overcurrent protection devices that are sized no larger than the ampacity of the conductors. It is important to select overcurrent protection devices that are appropriate for the type of feeder cable and the application. And remember to ground and bond your feeder system. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, while bonding ensures that all metal parts of the electrical system are at the same potential. The NEC requires that feeder systems be properly grounded and bonded to minimize the risk of electric shock and fire. The grounding and bonding system should be designed and installed in accordance with the NEC requirements. Ensure compliance with all local codes and regulations. In addition to the NEC, local codes and regulations may also apply to the installation of electrical feeders. It is important to check with your local building department to determine what codes and regulations are in effect in your area. Local codes and regulations may address issues such as permit requirements, inspection procedures, and specific installation requirements. Finally, remember to document everything. Keep detailed records of all aspects of the feeder installation, including the design calculations, the materials used, the installation procedures, and the test results. This documentation will be valuable for future maintenance, troubleshooting, and upgrades. By following these guidelines, you can help ensure that your feeder installation is safe, reliable, and code compliant.